So we are continuing with the NCERT textbook exercises. What are the various factors due to which the ionization enthalpy of the main group elements tend to decrease down a group? So when we talk down the group, the electronic configuration of the element stays the same. But the variation with respect to the size, the charge of the nucleus, and there's something called a screening effect that we have to consider. So in detail, we had discussed this in ionization enthalpy. For that, you have to, do check it out. The first ionization enthalpy values of group 13 elements are boron, aluminium, gallium, and thallium, 801, 577, 579, 558, 589. Now, why is there a deviation? First, let's look at the periodic table. So as we learned in down the group, when you go down the group, you have to, there has to be a decrease in the ionization enthalpy. But we notice that the values of ionization enthalpy of gallium is higher than that of aluminium, and thallium is also higher. Now, this is because of the screening effect. When we go from aluminium to gallium, gallium has the 3D orbitals. So 3D orbitals screening effect of these orbitals is way less than S and P. So the screening effect is basically these orbitals will cover up the nuclear charge in such a way that the outermost electrons you will not be able to get attracted by the nucleus. So what happens is, in case of gallium, you have the introduction of 3D orbitals. So here, as we know from here, you have the 3D subshell getting added up. So because of because of the less screening effect of the 3D orbital, the electrons in the outermost shell are held properly by the nucleus. So because of that, despite there being an increase in the atomic radius, despite there being another shell getting added to this particular element, gallium, so aluminium will have only 3 as a principal quantum number, because gallium has 4, which means there are 4 shells. But because of the ineffective screening effect of d orbitals, gallium's ionization enthalpy is actually quite higher than aluminium. Similarly, in case of thallium, you have the f orbitals coming in. Here, if you know, there'll be f orbitals coming in. And f orbital screening effect is even less than d. So the screening effect order goes S more than P, more than D, more than F. So F is least screening effect. And because of that, there will be a deviation from the general trend that we observe. So both of them are to do with the screening effect, but basically less screening effect of the D and the F orbitals. Which one of the following pairs of elements would have a more negative electron gain enthalpy? Oxygen or fluorine, fluorine or chlorine. Now from this particular data, we can say easily that oxygen is going to have, oxygen will have a less negative electron gain enthalpy than fluorine. So fluorine will be more, but compared to fluorine, fluorine will have a higher one. The reason being, it is very easy for these elements, first of all, to take an electron in. So the energy that is required for it is not very high. So that's why it's more negative. The energy released is not that high. So it's more negative. So in case of oxygen and fluorine, fluorine is obviously more, it is very easy for it to gain just one electron and get the inert configuration. So it's more negative than oxygen. Chlorine is higher than fluorine because fluorine has a small size, and because of its small size, the 2p electrons will have a repulsive effects between each other. So there's going to be repulsions between the electrons in the 2p shell, and because of that, the electron gain enthalpy of fluorine is less negative than fluorine is less negative than fluorine. How would you expect the second electron gain enthalpy of oxygen as most positive? Sorry, would you expect it as more positive, more negative, or less negative than the first? So we would expect the electron gain enthalpy for oxygen to be more. Uh, I mean, so the oxygen atom, when an electron gets added to it, it will have a negative electron gain enthalpy. The second negative electron gain enthalpy of oxygen would be positive because when it has a negative, when an electron is added to it, after this, there will be something called as Coulombic repulsion, and energy has to be supplied for us to overcome this repulsion. So because of that, the electron gain enthalpy of oxygen will be more positive. So from here to here, it will be negative, minus 141, if I'm not wrong. And from here to here, it will be more positive, or rather positive, because of the fact that when it goes from here to here, electron is getting already there is an extra electron, and that is going to have some amount of repulsions. When another electron has to be added, then it requires some amount of energy. Question number 22. What is the basic difference between the terms electron gain enthalpy and electronegativity? Now, electron gain enthalpy, the primary difference between these two is electron gain enthalpy is independent of its location. Like, for example, if you talk about oxygen, fluorine, that particular element is not bound to anything, okay? We in fact talk about it as an isolated atom, neutral isolated atom. Whereas electronegativity is measured when that particular element is actually bound to another atom. So let's assume there's a bond between carbon and fluorine. Fluorine likes to pull the electrons towards itself, right? So fluorine is more electronegative than carbon. So it's relative to the atom it is bound to. So definitions are: when an electron is added to a gaseous, neutral, isolated atom, energy is released. And this is called as electron gain enthalpy. Electronegativity, on the other hand, is a qualitative measure of the ability of an atom in a chemical compound to attract the shared electron. So in basic difference would be the fact that this is going to be a neutral gaseous isolated atom, whereas this is going to be in a chemical compound. Question 23. How would you react to this statement that the electronegativity of nitrogen on Pauling scale is 3.0 in all the nitrogen compounds? Now, if you think about it, if nitrogen, so electronegativity is a qualitative measure, and it is the ability of an atom to pull the electrons towards itself. Let's assume nitrogen is bound to an atom, to an electron, to an atom which has a higher electronegativity. Then obviously there'll be a change. So electronegativity is actually dependent on the atom that the nitrogen is attached to. And based on that, the value of the electronegativity will vary. And so the statement that in all the nitrogen compounds, the value of electronegativity is 3.0 might not be applicable. 24. Describe the theory associated with the radius of the atom as it gains an electron, loses an electron. So basically, this question just is a simplified version of the fact that the cation and the anion, what happens to the atomic radius when they are formed. So as we learned before, there was another question about the same, and we discussed about this in the ionic radius as an atom loses an electron, it leads to the formation of a cation. And when it does so, it leads to a decrease in the ionic radius. This is because the nuclear charge stays the same, but the number of electrons are less. So the nucleus is able to pull the electrons towards itself, and the radius of that particular ion is less. On the other hand, when it gains an electron, it leads to the formation of an anion, and the ionic radius increases. This is because the nuclear charge stays the same, but the number of electrons are going to increase. There's going to be some amount of repulsions between the electrons, and this leads to an increase in the ionic radius. To understand this in detail, do check out the video that we had where we discussed about the ionic radius. Next one, would you expect the first ionization enthalpies for two isotopes of the same element to be the same or different? First of all, an isotope consists of the same number of electrons. So the number of electrons is not going to change, but it has different number of neutrons. Protons is also going to be the same. So the effective nuclear charge is the same. The number of electrons is the same. So we would expect the ionization enthalpies for two elements to be on two isotopes of the same element to be almost equal or to be close, quite close. Question 26. What are the major differences between metals and non-metals? Metals and non-metals, we know that first of all, metals are on the left side, non-metals are on the right side, excluding the noble gases. So metals have a tendency to lose electrons, that is, they form cations, whereas non-metals have a tendency, oh, I'm so sorry, this is supposed to be gain electrons. So they form anions. And because they are losing electrons, they undergo the process of oxidation easily, whereas these undergo the process of reduction easily. So this means these are strong reducing agents and these are strong oxidizing agents. We had discussed about the oxidizing and reducing nature of various elements, or rather oxidation and reduction, the explanation about what is oxidizing agent, what is reducing agent in detail in the I think the last video about about this with respect to this chapter. So do check it out. This metals have a low ionization enthalpy because it is easy to remove electrons. Non-metals, on the other hand, have a high ionization enthalpy. Metals have a low negative electron gain enthalpy, which means energy is required for the addition of electrons into metals. High and negative electron gain enthalpy because they don't require that amount of energy for the addition of electrons. Metals have low electronegativity because they don't have a tendency to pull electrons towards themselves. Non-metals, on the other hand, have a high electronegativity. Metals form basic oxides and they form ionic compounds, whereas non-metals form acidic oxides and they form covalent compounds. We had discussed this again when we talked about the chemical reactivity. One more important thing, this is not tendency to lose electrons. This is the tendency to gain electrons. Okay, so so they form anions, these form cations. In the next video, we will be discussing continuation of the NCERT question.